And let's get started then. So what this talk
Navin,
is going to be.
please click on the present button so it comes in full screen.
Okay, sorry.
Thanks.
Okay. So what are we going to talk about today? First of all, I will explain you all the business problem we were going to solve with this tool and how this tool came into existence and what was the solution proposed and the implementation which we had done in the current version and the tech stack and what are the limitations and how are we going to tackle those limitations going ahead. So what are the business problems? Uh, as we can see today, the web applications are becoming complicated, and those complications are not only limited to the software, but also they have migrated to the infrastructure management as well. So it's not that things were not complicated before. Before we had to deploy our own hardware, procure our own hardware, manage those, and there was the management has had to hire people to do all those things. But now since we have a cloud technology, we don't have to do that. But still, managing the virtual server is also becoming complicated because as your web application grows, your number of servers grows, and you have to monitor them all and see how they're performing to manage your cost. And also, once you have all those resources in place, you have to do the capacity planning, how those resources are going to coordinate with each other. So all these are the problems which we are going to solve with this tool. So why do we need capacity planning? First of all, if you have a web application, it's in a modern web application, you need elasticity. It has to scale at need and shrink at if we don't need the resources. And if you are designing a application, you have to make sure that that application's architecture is as such that it scales with the infrastructure. It shouldn't have a component which becomes a bottleneck and doesn't allow you to do auto scaling and stuff like that. And cost reduction. So if you have particular set of resources and if you can do something with less amount of those, then why wouldn't you do that? Pricing and budgeting. So if you have a release going on and this need to procure more hardware, obviously the management is going to ask questions and there will be some time lag in there. So to address those problems, selecting the cloud provider, there are a number of cloud provider, how they are going to provide those capacity planning, how their infrastructure is organized, and how we are going to integrate in that. And of course, the management also needs to be answered. Like, if we need certain amount of capacity, then why do we need that? So this capacity planning is also important part of Perfaccion and help you to answer all those questions. So what is the solution overview? With our, as traditionally, once you have your sprint is done, you have a functionally tested code which is working fine, you used to manually test that, write scripts, try to generate load, artificial load to see the behavior of your web application in various scenarios. So all that used to be a manual process. With Perfaccion, we have automated that. You just have to provide your API specification with Swagger, or if you don't have Swagger, you can use our own UI to specify APIs. And Perfaccion does the testing on various load patterns to generate and shows you the report. So implementation overview. So how all the automation is carried out. So I'll explain that. First one, once you submit your API specifications, uh, Perfaccion does the basic instance setup. Like we need if it checks like does it give all the CPU and performance metrics which we require for the algorithm. Then It checks with the basic minimum load. Does your application even survive that very basic load? It's like 1 request per second. Then once it is, make sure that instance is working correctly, your app is working correctly, then we start our performance testing. We slowly increase our load from 10 rps. Suppose you have given 1000 rps your requirement is, so it divide. We are using algorithm to slowly put load on your web application so that we can detect pattern in your response time. So it will start with 50, then 100, then 200. So if your web application fails at 200, then it tries between 150 and 200. If it again fails at 200, then it goes between 150 and 175. So like that, it manages to find a breakpoint. So initially, if you have set a T2 medium instance, it tries to find the breakpoint for that T2 medium instance. Then it upgrades the resource based on the data which we have collected on the that instance. We try to decide, like, is it a CPU intensive application, is it memory, or is it network? So suppose algorithm has concluded that it is a memory intensive application. Then based on that conclusion, we have a decision tree. So initially we test your web application on T2 medium, and it decides, it tries to infer that is it CPU, memory, or network. So if it has this came to a conclusion it is a memory based intensive application, it tries all these instance R4 large, then R4X large. So one must be asking a question like, why are we not testing it all possible combinations? The problem is there are so many instances provided by AWS. You will just end up testing instances and not deploying application. So to narrow down those list of instances, we have used this algorithm. So once you have tests all those instances, T2 medium, R4 large. Suppose it finds that R4X large is sufficient. It does not need to test above those instances, and it stops the test over here. And it ends the test, and it sets that instance to that level, X4, R4X large. And if anyone has any questions so far, because the algorithm is a bit complicated.
Munawar, please continue. We can take the questions towards the end.
Okay. So talking about the tech stack, in the front end is Angular, back end is Node.js. Overall architecture, if you talk about, once you have submitted your request, like I want to test my web application, it is the messages are queued. The queue which we use is RabbitMQ, and backend is a slave node which generates the load and reports back to the web application, and the data is stored in Mongo. Our instance we are using is EC2. So let me show you a demo so things become much more clear. So if you, once you are logged into a web application, you will be greeted with this page. You have to fill in the test name, the host, maximum request per second you're looking for. It can be 1000. So duration is how long do you want to carry out each test. Like you can test for 10 minutes on each particular concurrency, 10, 50, 100. Resource constraint is you don't want to cross your resource beyond this % of the utilization. If it is, then it's a red flag. We should stop the test. As I talked before, that you don't have to manually do all this. You can just import your Swagger and it will be all pre-filled. So let me show you one such. So as you can see, it has pre-filled over here. This credential you have to provide your AWS key, instance region, and instance ID. As you can see, the API form is pre-filled. This is the post request on this host, and this is the API path. Header, you are giving the cookie. It's an authenticated API, so you have to give that. Headers, request params, and if you have a JSON, then you can provide JSON over here. So in testing, what happens, you have same API, but you want to test around with different parameters. So you can use a clone over here. So it creates a clone of that API, and you can change the data over here. There are various methods supported. You can play around those, whatever your API has. And if you have more tests, then you can add more tests from in the bottom column and specify over here. Etc. etc. So once you have filled the whole form, you can submit the form. A test takes a little long time to execute, so I'm not going to show you how it carries out, but I will show you the report. Once you have submitted the test, it will be in a waiting state, and once it has done all the instance setup, basic testing, it will go into running. And once it has completed, status will be shown over here. So we'll see this report for this Acmer Node.js project. As you can see, it took very long time to execute, 13 hours. It's too much, but we'll see how this will work on this limitation. So once you get into this report, it shows you what all various instances it has tested. I have previously discussed, like, there was a resource tree which was tested. So this is the list of all resources it has tested. And once it has finished testing, it automatically sets that instance to active. As you can see over here, if you want to change that activity, you can click on set instance, provide the command, it will set the instance. Perfaccion also fetches the instance pricing from the AWS website and gives over here. So user can have judgment like what will it cost like. So we can see that after testing on general category, it has concluded that it was a memory kind of application. So I need to test on memory applications. For testing purposes, I had trimmed down the tree to very basic one. So it has only tested on 2 instances over here. On price versus request per second graph, you can see the overall difference between the pricing of your instance as it grows up. Okay, so let me show you the Medium report. Over here, it has tested all these APIs, post, request, and we can, clicking it, we can see much more detailed reports. This was the request which we had made over here. As you can see, this is the overall summary of your application. This is how CPU was consumed. CPU consumption was done, and this is the memory consumption. It has not crossed the threshold, and as you can see the spikes over here, this was the different test intervals, 5-minute test interval. So the load went down and it came back again up. This was the overall API response time, minimum, maximum, concurrency, various parameters. You can play around with the graph. Our request report statistics will give you details on each request which it has carried out. So if we told that we want 50 RPS, so it started with 1.5, then it went on and till 50 it concluded that okay, it's good enough to go with this. If you click on each detail, it gives you the CPU utilization and memory utilization for that particular concurrency test. In the previous graph, it had merged all those individual graphs to create this whole graph. And if you go back, T2 micro, it has, as you can see, all the tests failed because T2 micro is a very small instance and app cannot survive on that. As you can, if we go into that report, it sees, if you can see that it was a failure, and the reason for failure was connection refused, timeouts, and request was taking too much time, CPU utilization, memory utilization. So this was the reporting part. Uh, does anyone has any questions so far? Okay, so I'm
So we
going
have
to go
one
ahead.
question from Anup. He asked, is it
Okay.
possible to optimize the performance for a cognitive load, say year-end sale, where huge hit ratio is expected?
It can give you like how will your application behave in such load, but it cannot itself go and optimize it. That is, it will help you to identify that there's some problem in your code and you have to address that bottleneck. If you go into the graph details, you can get like, is it consuming too much of CPU or RAM? So it can help you in that way. Any other questions, or have I satisfied your question?
No,
Oh, I can see. Okay, should I go ahead?
Okay, he has a follow-up question. So prediction is possible?
Since we have the data, we can put the algorithm. We have data algorithms, we can do that. Sure. Time series data analysis. Any other questions?
No, please continue.
Okay. Okay, so what are the current limitations of the platform? It right now, as a part of the first version, we have created for monolithic web application testing, but going ahead, we are planning for distributed app testing. It supports only for AWS. We are looking for Microsoft and Rackspace in the coming quarter. Test suite are sequenced in the sense you have I have shown that problem before. It takes a really long time. We can parallelize the testing by creating multiple test instances and running test in parallel. Right now we are restricted in load generation only 1000 RPS, but if we distribute our load, uh, if we have multiple instances to generate load, then we can even generate 10,000 RPS. We can even use AWS Lambda that can simplify our job. Instead of creating a node to generate instance to generate load, AWS Lambda does that on the fly.
Hey Munawar and Jane, this is Nitin from Motorflux. Can you guys hear me?
Yes. Hi.
Hey, so I do have one question. I'm sorry I joined a few minutes late, so you may have covered it. So I understand this application is to test which instance of instance type in AWS would be best for your workload. So the tests that you are running, are they are custom for any application that you want to run and test it on that, right? Are these a performance test for any specific application, or these are general tests and you can use it to test any different workload?
It can, if your system is a REST based, you can test it. It's a general REST based backend testing. It not only provides you a performance test, but it also recommends you what AWS infrastructure is better for your web application.
But if it is a REST-based system, I would still have to write test scenarios to to test the
Yes,
application,
right.
or if I already have some performance test, I can use it?
Right now, scenario-based testing is not supported, but you can give your API specifications from Swagger. If your API are documented in Swagger, then it becomes really simple. Perfaccion is entirely based on REST APIs, so you can even script it and integrate as part of your Jenkins CI/CD process.
Okay.
Does that answer your question?
So, yeah, it does. And maybe let me put that in a different way. Let's say I have an application and I don't have a performance test. I don't have any. It does have REST APIs, but I don't have any existing tests. And if I want to use Perfaccion to see which specific instance in AWS would be best for my workload,
Okay.
I will have to do some work to create those tests and kind of
Yes.
use Perfaccion, right?
So,
Yeah,
now
yeah.
let
You
me
have to.
answer this. Maybe it's not clear from your previous answer. So, Nitin, what we're saying is Perfaccion allows you to test the application two ways. One, you can use the interface and put in all your API definitions in terms of what's the URL, what's the parameters you need, what is the authentication mechanism, and things like that. Or you can use your Swagger definition, import that in Perfaccion, and then Perfaccion will call each API, put the required load, and based on the worst performing API, it will tell you what's the AWS instance that is required. So it starts with, say, a micro or a medium instance. It monitors the CPU and memory usage. Based on the CPU and memory, it tells you whether it's a CPU intensive application or memory. And it has this branching logic to say, AWS has these decision trees, right? To say, if it's memory, then you need to use these instances. If it's CPU, it's something else. So Perfaccion finds that for you and finds out which is the most optimal AWS instance based on your application requirement.
Yeah. So, and then I'll give you a couple of inputs. The typical customer scenario that we are seeing, and so one is I have some ASP.NET applications, Java application, and that has been there for the last few years. And now I'm ready to move it to cloud. I don't even know whether it's a REST API based, but assume that it does support REST APIs. And that I want to move to the AWS. What will be my effort to use Perfaccion to understand what specific instance type I could use?
So
and the second scenario is,
yeah,
I have put it already on, let's say, M1 medium, M2 medium, something like that. And I'm not getting the right response time, or my costs are higher. Can that, and this is more likely to happen. So I've already done that. I don't have tests, but I have I've run it on M3 medium or something. And can this be used to further optimize, whether it's to upgrade to a better instance or lower it because I'm wasting resources?
Yes, absolutely. So basically what Perfaccion says is you need to deploy it on the minimum instance on AWS. So say you deploy it on a micro instance. Then you start the Perfaccion test. And in that test configuration, you need to mention what is the required RPS. So say I require 500 RPS requests per second. My application needs to, that's the benchmark I need. So you put that information, you put in your AWS credentials, you put in all your API definition. Perfaccion starts the test with 500 RPS and sees what number you're able to achieve at that micro instance. So say, for example, it's able to achieve only 250 RPS. It would then upgrade the instance till it gets a minimum of 500 RPS. So that way it would tell you that, at 500 RPS, for 500 RPS, you need, say, a medium instance with 2 GB RAM and 2-core CPU. What I think, Munawar, you've not covered the monitoring part. What we've also done further is once your system is live, you can add a monitoring engine on your server, and this server would give you. You need to install a script. This would pass on the CPU, memory, RPS information to Perfaccion. Perfaccion will keep monitoring to say that your actual RPS is only 200, but your desired RPS was 500. So maybe you don't need a medium instance. You should ideally go in for a micro instance. Or the other way, your actual RPS is now hitting to 750 and your medium instance is failing. So maybe you need to now upgrade it. So it will do a Perfaccion test again and find you what is now the best suited based on your current RPS. So again, two ways here. One is a fully automated where you give full control to Perfaccion to say, you create a new instance, run Perfaccion test when it crosses the threshold. Once everything is working fine, you add it to the load balancer and kill the previous instance. Or we just notify the user to say that your system is now going beyond the threshold or not being used as much as you imagined it would. Should I initiate a Perfaccion test on a new instance? Once the user approves of that, then that whole process can be executed. So that will not only help you decide what is the instance requirement and therefore your cost during the initial deployment, but also during the live production instance. And you can better control your cache outflow. Does that answer your question?
Yes, Jane.
Yeah. And the other thing is, in AWS, you have things like autoscale, and so as developers, as DevOps, we just take the easy way out. We say, okay, fine, I think we need a medium instance and let's just put it on autoscale. And when the threshold goes beyond what the medium instance can handle, AWS would just spawn a new instance of the same configuration. Now you realize that your cost is suddenly doubled because it's created 2 medium instances. But what Perfaccion is aiming to do is maybe you don't need 2 medium instances, you only need 1 large instance, which will bring down the cost. Say a medium instance cost you $100 and 2 instances of that would cost you $200. Instead of that, you could probably have 1 large instance of $150. So that's the basic assumption with which Perfaccion is built. So trying to do a better cost optimization and server optimization.
Okay. And this Perfaccion is it it's a Accion product, kind of a tool. It's not a client name, right?
No, Perfaccion was built by Accion for Accion. We are in the process of creating it into a SaaS application. So it's already hosted on the cloud. We're looking at a scenario where users can come and subscribe online and run a test using the Perfaccion site. So currently it's free to use for everyone in Accion.
Okay.
Any more questions, anyone? Yeah, Munawar, you want to quickly demo the monitor?
Okay. So there's a plugin, Perfaccion Monitor on GitHub, which you have to install it on your server. That plugin will ask you to point to your log files, web application log files, and it will send all the, and it will ask you the credentials. So credentials you can create by creating on this site, and it will app name, host, host is from where your traffic is going to come, and duration is basically Perfaccion will collect all those data, and after specified duration, it will run an analysis that was your instance consuming too much of resources or too less of resources. So if I say 3 hours, so after every 3 hours, it will do that analysis. In this, you have to link your monitor to your test suite. So this will help us to identify what all APIs we need to, what all APIs logs we need to catch, and ignore all the unnecessary logs. And once we have added that, it will give you credentials. Just hold on for a second. Will
Whenever that's fine. I think you may want to go back to the test suite and see if there's anything else you want to cover. We're running out of time.
Okay, I guess we are done with this. Monitor was only one new feature in our next release. If anyone has any questions, then they can ask. No questions.
Okay, so Perfaccion is available on perfaccion.com. You can go and sign up there, and you can try some of your application using the UI interface. Feel free to reach out to Munawar or me if you have any questions, feedback, bugs. It's still, it's a continuous development process. So there's always new things coming up, new issues may come up. So please feel free to reach us. Thanks a lot, Munawar. That was a good presentation and demo. And thank you everyone for joining in. And I'll see you next week with another demo. Thanks and have a good day. Bye-bye.
Okay. Thank you.